Welcome back, everybody. I apologize for not being able to be there with you today, but I have a dental appointment that I cannot get out of. I hope that you had a fantastic break and you're all ready to go to finish up the semester. We've only got 3 more weeks of classes and then you'll begin to your final exams. Most of you will be writing diploma exams as well, and that's going to start happening very, very shortly. What we're going to do today is spend some time reviewing what we learned on the very last day of classes before our Christmas break, which is how to use the sine law to find a missing side. After I review what the sine law is, we'll do a few examples where we find a missing side, and then we're going to move on and look at finding missing angles with the sine law. At the end of this lesson, you're going to have an assignment that needs to be completed and turned in for marks dealing with using the sine law to find missing sides and missing angles. So to begin with here, this is a review of what we studied before the Christmas break. It was called the sine law, and I want to back up to previous parts of this course where we solved problems that involved right angle triangles. Remember, a right angle triangle is a triangle that contains a 90-degree angle. So for example, that is a right angle triangle. This is a right angle triangle. There is a 90-degree angle in here. When you're dealing with a triangle that has that property, it has a right angle, it contains a hypotenuse, and depending on the angle we're talking about, one of the sides is called adjacent and one of the sides is called opposite. The longest side, of course, the one across from the 90-degree angle, is the hypotenuse. If you're dealing with that kind of triangle, which we have in the past, you can use sine of an angle equals opposite over hypotenuse, cosine of an angle equals adjacent over hypotenuse, or tangent of an angle equals opposite over adjacent. You can also deal with triangles like that by applying the Pythagorean theorem, where you take the square of the hypotenuse and it's equal to the sum of the other squares for the other two sides. A triangle that does not have a right angle in it is a triangle that you cannot use those tools for. So if you think of SOHCAHTOA as a tool and the Pythagorean theorem as a tool, they are useless for non-right angle triangles. And those non-right angle triangles are called oblique triangles. So how do we use math and trigonometry to work with oblique triangles? The answer is you use the sine law, and you can also use what's called the cosine law, which we will get to in a couple of days. Just make a note to yourself, though, that the sine law, and this is for everybody, but particularly for those of you that might have been absent on that Friday before the break. The sine law is not the same as sine of theta equals opposite over hypotenuse. That's a different thing. When you talk about sine of theta equals opposite over hypotenuse, this, which is part of SOHCAHTOA, is not the same as the sine law. The sine law is something entirely different. And again, this is for everybody, but particularly for those people who were not here when we studied this. These two things are different. The one highlighted in yellow is something you can use for a right angle triangle. The sine law is something you use when you don't have a right angle triangle. So what is the sine law? Well, to begin with, I want to review the notation of a triangle. The triangle ABC that I'm going to show you up here on the screen will look different in some ways than the triangle that's on the paper that you're writing on and following along with. My triangle looks like that, and you can take a look down on your sheet of paper and see how that's different than your triangle. But it is the same as your triangle because it has an A, a B, and a C for what we call each of the vertices. A vertice is a vertex. Vertices is just the plural way of saying more than one vertex. So if you like, you can use the word corner. There are 3 corners in this triangle. One is labeled capital A, one is labeled capital B, one is labeled capital C. And although this is probably pretty obvious for most of you, It's crucial that you understand this notation. The way we label the corners or the angles or the vertices, whatever you'd like to call them, is we use capital letters, but the sides are labeled with lowercase letters. And the side and the angle that have the same letter, for example, the capital A and the lowercase a, are always across from each other. So if you take a look at the screen right now, you can see that these two items are across from each other. And if you take a look on your paper and you look at where capital A is and lowercase a is, you'll see they're across from each other. On my diagram, that means that I'm going to label side B over here. Side B and angle B are across from each other. And if you look on your paper, that's the same for your triangle. And finally, wherever angle C is, side C will be across from it. So what does the sine law say? The sine law says that when you use these pairs of side angles, when you use a side angle pair for a particular triangle, the length of the side over the sine of the angle is going to give you the same thing no matter which pair you use. You'll see how this works in detail in a second, but one of the things I mentioned on that Friday, and this is fairly important here, is that this formula, A over sine A equals B over sine B equals C over sine C, is not something you would ever use all of. What you would do is use part of it. So for a particular problem, you might say A over sine A equals B over sine B. For a different problem, depending on what you want to find, you might use B over sine B equals C over sine C. Or you might need to use A over sine A equals C over sine C. And I know it's been a couple of weeks. I know that. It's been a long time. But for those of you that were here in class on that Friday, I think you can think back, and many of you will probably remember, that we never even really used the formula anyway. We just took a side over the sine of an angle equals a side over the sine of an angle. Now, one final thing before we get to some examples. Sometimes it might be useful to write the sine law upside down, so to speak. So rather than having the sides on the top and the sines of the angles on the bottom, we put it the other way around. You can make a note to yourself, you can write this down, that typically speaking, if you want to find a missing side, then I recommend using this form of the sine law, whereas if you want to find a missing angle, I recommend using this form of the sine law. I just recommend using the form of the sine law where your unknown is on the top. Rearranging that is easier if your unknown is on the top than on the bottom. So let's get going here. The first three examples we're going to do are really examples that we looked at doing on that last day of classes before the break. They're not the same examples, but these are ones that you should know how to do. So you were asked in this particular question, example 1a, to find the length of side A. So when we look at this triangle and we identify where angle A is 112 degrees, that means that this side must be side A. And that's what we want to find. This is our goal. The only way you can use the sine law, and I'm not going to go into really deep detail about why this is the case. You will discover, the more of these that you do, why this works this way. The only way for you to use the sine law is if you know a pair that are across from each other. So, I mean, if you like, you can call that 35 degrees angle C, and you can call this 25 centimeters side C. But the bottom line is you know a pair. And when you set up the equation for the sine law, what's going to happen is you will always have one side of the equation with numbers that you know, and the other side of the equation with half of the pair that includes the thing you're trying to find. So we're trying to find side A. We're trying to find side A. We can leave that as A over sine of 112 degrees. So on the top of each side, we have a side. On the top of each side of the equation, we have a side length. And on the bottom, we have the sine of the angle that's across from that length. So now you're going to solve that for side A. You want to make sure that your calculator is in degree mode. When you cross multiply, what you're going to end up having to do is take 25, multiply by sine of 112. My smartboard is a little glitchy right now for some reason. Let me see if I can fix that. Multiplied by the sine of 112 degrees. And then, of course, we have to divide by the sine of 35 degrees. We've done enough cross multiplication in different parts of this unit that you should know how to do this. I think many of us by now can just look at that equation that I'm going to highlight in green. You know what to do to get A by itself. Some of you might choose to use the fish method. Bottom line is, you should know that you take sine 112 degrees multiplied by 25 divided by sine 35. So let's see what we get. And I don't think I put in your handout how many decimals to have. I'm just going to tell us that we want one decimal place for anything that we do today in this lesson. Let me grab my calculator. What are we dealing with here? 25 multiplied by sine of 112. And then if you have a graphing calculator, you need to close the brackets on that 112 degrees, divided by sine of 35. I mentioned that you should check to make sure you're in degrees. Let me just double check with mine. I am in degrees. So what I get is 40.4 centimeters. I'll just wait a minute here to make sure that everybody is able to get it. And Mr. DeRose will pause the video if it needs to be paused. All right, let's try another one. Find x. So in this particular case, and this is what we did on that Friday, it's not that difficult. There aren't even any labels here, never mind A, B, C. But looking at where x is, if you were trying to find x, then you need to know this angle. The only way you can use the sine law to find one thing is if you know the other half of the pair that that thing is part of. And as well, the only way you can use the sine law to find a thing is if you know a full pair someplace else. So we know the 105 centimeters and the 73 degrees are a pair. We're going to end up doing that, so we can write 105 centimeters over the sine of 73 degrees is equal to x centimeters over the sine of this angle here. We need to know that angle because it's across from the side we're trying to find. Well, that's child's play. That's like taking candy away from a baby. You have a triangle that you're looking at. You know two of the sides, you know two of the angles have measures of 73 degrees and 51 degrees. I think when we add those together, we get 124 degrees. We know that all of the angles in a triangle have to add up to 180. So we can take 180 degrees and subtract that 124 degrees and end up getting what I believe is 56 degrees. but I'm just going to double check on my calculator. It's 56 degrees, and I'll just double check that 73 plus 51 is 124, and it is. So that means that this angle in here is 56 degrees. So I can put 105 over sine of 73 degrees is equal to x over 56 degrees, and then the rest of the problem is easy. Now you're just going to solve for x. Since x is on the top, cross multiplying is really easy. It's going to be 105 multiplied by sine of 56 divided by sine of 73, and we will be done. That's a multiplication sign. Let me fix that. So 105 times sine of 56 over sine of 73. Let's see what happens here. Remember, depending on your calculator, you may have to close the brackets on that 56. So I get 91. X is equal to 91, and I think it was in centimeters. I'll just double check. Yeah, it's centimeters, because the 105 is in centimeters. Once again, Mr. Jaros will pause the video if it needs to be paused. Let's do one more question where we're finding lengths of sides of a triangle. This is a bit of a word problem. You're given the diagram though, so it's not too bad. Allison and Bobby are at two different locations, and they're going to leave those two campsites. It turns out they're in a campground, and they're going to walk from where they are to the confectionery to meet up. And we want to find the distance that each one walks. So there's two things we want to find, and we can call them whatever we like. I'm going to stick with the proper notation, that if this is point A, where Allison is, and that angle A is 61 degrees, then we can call this side little a, or lowercase a. Similarly, if this is B, where Bobby is, then 88 degrees is angle B. That means this side, which is across from the 88 degrees, is lowercase b. We need to find those two things. And you want to be really careful here. Listen carefully to what I'm about to say. This A that I've written in the diagram, this A is the distance that Bobby walks. Just take a look at the diagram and look at where Bobby starts and look at where the confectionery is. A is how far Bobby walks, whereas B is how far, and I might as well highlight this in yellow because then we have a pair. On the other hand, this B is how far Allison walks, because Allison has to walk that distance at the bottom. So how are we going to do this? We do need to figure out what this other angle C is. We do have a third pair here, and we need to know that angle C in order to proceed. Let me explain to you why. If we want to find side A, you would say A over sine of 61 degrees equals, we have to use the 2.5 over sine. We need to know what angle goes here. And this angle that goes here is whatever angle C is. So that's a pretty simple thing to do. Let's do a quick calculation with that. We've got 88 degrees plus 61 degrees, which gives me, I think it's 149 degrees. You should be following along on your calculator, I hope. That means that the remaining angle has to be 180 degrees minus that 149 degrees, which I believe gives me 31 degrees, but I'm going to double check all of this with my calculator. 88 plus 61 gives me 149, that's right. Now I have to take 180 minus that 149, which gives me 31 degrees. Okay, so this is 31 degrees in here. And now we can complete this, because now we have a pair. We know the green pair. And in terms of the yellow pair, we're trying to find half of it. So we can write A over sine 61 equals 2.5 kilometers over sine 31, which means that A will be equal to 2.5 multiplied by sine of 61 divided by sine of 31. Pretty straightforward. The thing I had mentioned to the class on that Friday before we took our break is that some of you will discover or feel as though the sine law is easier than SOHCAHTOA. You don't have to worry about adjacent or opposite or hypotenuse. You just go with pairs. A over sine A equals B over sine B equals C over sine C. So let's calculate this. 2.5 multiplied by sine of 61, close my brackets, divided by sine of 31. So this time what I get for an answer is 4.2 kilometers. Now, I'm not done. This is kind of done, but there's going to be more work I want to do with it. So I'm going to write 4.245. A equals 4.245 kilometers. That means Bobby walks. This is the distance Bobby walks. This is Bobby's trip. If you look at the diagram, here, that distance A is actually how far it is from Bobby to the confectionery. So that's the distance Bobby walks. Let's do the same thing now for finding side B. I don't need this anymore. I'm just going to erase it to give me a bit of room. I can put B over sine 88. This time equals 2.5 over sine 31. Which means B will be equal to 2.5 multiplied by sine 88 divided by sine of 31. (2.5 sine 88 over sine 31). About 4.85 kilometers. So B, in the diagram, B is 4.85 kilometers. But when you take a look at where B is the distance that Allison walks to the confectionery. So this distance is the distance for Allison. This is Allison's trip. So we've got the answer to how far Bobby walks. Bobby walks 4.2 kilometers. We've got the answer for how far Allison walks. Allison walks 4.85 kilometers. There was also this question that's peeking out at the top of the screen that says, who walks further and by how much? Well, you can see that Allison walks further. The distance Allison walks, 4.85, is more than the distance Bobby walks of 4.25. By how much? Well, we need to take this 4.85 and subtract and subtract the 4.245. That's probably enough decimals. We're not landing people on Mars here. It doesn't have to be perfect. So the extra distance that Allison walks is about 0.6 kilometers more. I'll just double check what I got there. Sure, 0.6 kilometers more. So that's a review of what we did on that day before the break. Now let's move on and let's do two more problems, which are really, really simple. It's just that we're finding angles instead of finding sides. So if you turn the page in this little handout that you were given today, we're going to look at two new examples where we're finding an angle with the sine law. And here's the first one. Nothing has changed, everybody, in terms of a strategy. If you want to use the sine law, then you need to know a complete pair. And we do. We know one of the angles is 82 degrees and the side across from it is 15 centimeters. If you want to find a missing thing, angle B in this case, if you want to find angle B, then you need to know the side across from it. And we do. So another way to put it is to find half of a pair, to find half of an angle side pair, you need to know a full angle side pair and the half of the side pair that you're trying to find the other half of. So you need to know yellow and half of blue, which we do. I'm going to write now the sine law, but I'm going to put sine of angle B over 9. Because I'm trying to find the angle, it's easier, my feeling is, it's easier for students to find the missing thing if it's on the top. And that means we can write this is equal to sine of 82 degrees over 15. And we're going to solve that now. So when you cross multiply here, because it's sine of B over 9, all we have to do is multiply the other side by 9. You're going to have 9 times sine 82, and then you divide by 15. That's a 9, not an A. If you want to do the fish thing, you can do the fish thing, but I don't think it's really necessary for most of us. So let me see what we get here. 9 multiplied by sine of 82. 82, just want to make sure, yep. And then divided by 15 gives me this number, 0.59416. 0.59416. That is not the angle. That is the sine of the angle. And hopefully you remember, just like working with SOHCAHTOA, that if you're trying to find the angle, at this point what you do is you take the inverse sine of that number, or the second sine of that number. On my calculator, I hit the second key, then the sine key, and then I can enter that number, 0.59416. I don't think you really need to go more decimals than that. It will be close enough. And this is the angle in degrees, 36 degrees. And that's the answer to the question. By the way, now that you know this is 36 degrees, if you wanted to, you could very easily find that angle at the top of the triangle because you know two of the three angles now. Anyway, that's the answer to question 3A. And the final example we're going to look at is 3B. We're asked to find angle X here, so let's identify. You can circle if you don't have a highlighter, which you probably don't. You can circle the pair that we know. You know 40 and you know 38. Unfortunately, the thing we're trying to find doesn't match up with a side we know. So we cannot find angle X directly, but what we can do is the following. We can use the sine law to find out what this angle is. And if we know what that angle is, then we can use the fact that the three angles have to add up to 180 degrees to find angle X. And that's what we're going to do. I guess let's call this angle something. We can call it angle Y if you like. So I can write sine of angle Y over 50, because 50 centimeters is across from angle Y, equals sine of 38 over 40, which means that sine of angle Y will be equal to 50 sine of 38 over 40. Give everybody a second to calculate what that is. I'm getting 0.76957 something, doesn't really matter what exactly. Now, of course, what you have to do is find angle Y by taking the inverse sine of that number. And I'm getting about 50 degrees. We'll say 50.316. Because we're not done. This isn't our final answer. We still have to find that top angle in a second. So I'm going to carry more decimals here. 50.316. So this 50.316 degrees plus the 38 plus x has to be 180. So I'm going to take 38 plus the 50.316 degrees. And that gives me, what, 88.316 degrees. And I have to take 180 minus that to get the answer for angle X. Let me get rid of this. About 91 point something, I think. So I'm going to add the 38. I'm going to add the 38. Then take 180 and subtract that, which gives me, well, that can't be right. 180 subtract that, which gives me 91.7 degrees. And that's our answer for angle X, 91.7 degrees. This is the answer to the question. So when you're using the sine law, all you are doing is taking the length of a side, maybe it's labeled as d, over the sine of an angle that goes across from it, and setting that equal to the length of a side divided by the sine of the angle across from it. It doesn't matter whether they're A's, B's, and C's. Or if you're finding an angle, maybe you would flip it over first. It doesn't really matter. I just think for some students it's easier to have the thing you're trying to find on the top. So Mr. DeRose is going to hand out the assignment. The assignment is due tomorrow. And I would like you to show the work. What I consider work is the following. If we just go back and take a look at, say, 3A, the things that I need to see for a question like this would be, I would want to see this. I would at least want to see this, and then your answer. I don't think you need to show every little detail, but I want the main steps, your substitution, and then the results of your calculations. And if you're finding an angle, then that means you've got 3 things to write. If you were finding a side, really you just need to show your answer as well as your substitution. You don't need to show that second step. So get to work on that, please. I haven't made the assignment yet, but I'm going to look at how long this video ends up being. And the assignment will be a fair length that I think some of you, I guess most of you, should be able to get done in class if you sit down and get to it. Okay? So it's due tomorrow. If you don't get it done by the end of the class, I'm going to be taking it in at the beginning of tomorrow's class. Once again, I apologize for not being there today. I would much rather be working with you than doing anything else, really. And I hope to see you all tomorrow. Take care.